Nuclear Chemistry, Part 6, Fission and Fusion. In this video, we're going to take a look at fission and fusion. Nuclear reactions can involve enormous changes in energy. This is a result of Einstein's most famous equation, E equals mc squared, which shows that even a little bit of mass from the nucleus can be converted into a tremendous amount of energy. A nuclear bomb is way more powerful than a conventional bomb, using dynamite combustion reaction, for instance. Or, when it comes to power plants, nuclear power plants can produce way more energy with less fuel than a coal-burning power plant. There are two major types of nuclear reactions that we're going to consider in this video: fission and fusion. Fission occurs when an atomic nucleus splits apart into smaller nuclei. Because fission has two S's that split the word in two, you can remember that fission is the splitting of nuclei. When nuclei split, it releases a large amount of energy, which can power things like a nuclear power plant or an atomic bomb. Here's an example. It's actually the same reaction used in most nuclear power plants, and in Little Boy, the atomic bomb that was used in World War II at Hiroshima. If a neutron runs into uranium-235 nucleus, it can fizz into barium-140 and krypton-93. The process produces 3 more neutrons and a large amount of energy. To give you a sense of scale, a single pellet of nuclear fuel, which isn't even pure uranium, and it isn't even pure uranium-235, the fissionable kind of uranium. Anyway, a single pellet, about the size of an eraser on a pencil, can release as much energy through fission as burning all of the gasoline in a large 250-gallon tank. Yeah, that's a large amount of energy. The major problem associated with using this reaction to generate electricity is that the waste products are radioactive, so they've got to be dealt with appropriately for safety. Fusion occurs whenever multiple nuclei come together to make a single larger nucleus. The nuclei fuse together and release a huge amount of energy. Fusion powers things like the sun, and all the stars, and modern nuclear weapons. This example is a simplification of the process that takes place on the sun, all the time, day and night. Hydrogen-2 fuses into hydrogen-3 to produce helium-4 and a neutron. A single gram of hydrogen undergoing fusion can produce as much energy as burning 5,000 gallons of gasoline. That's a literal truckload of gasoline. It would be great to use this process to generate electricity, because the process produces no radioactive waste products. We don't use this process to generate electricity because extremely high temperatures are needed to get it going. You know, like as hot as the sun. The energy used to heat up the hydrogen and get it to fuse into helium would be wasted, and you'd only get about as much energy as you put in to get the fusion going. So it isn't efficient or economical enough to generate electricity with fusion reactors. At least, not yet. Let's check your understanding of these two processes. For each of these 5 items, determine if it's describing a fusion or a fission reaction. Pause the video if you're going to need more than 10 seconds. It looks like number 2 and 3 are showing fission reactions, because a large nucleus splits into multiple smaller nuclei. Fusion is described in the others because fusion is when small nuclei combine together to make bigger ones, and because fusion is what powers the sun. Now you know a little bit more about nuclear fission and nuclear fusion. Thanks for watching.